Okay, good afternoon student. Today we will learn about the iterative kernel of a function or iterative kernel of linear integral equation. Let us take the freedom integral equation. This is the freedom integral equation in which k of x comma t is a kernel. The process for finding the iterative kernel is k1. The first step, first kernel k1 x comma t equal to k of x comma t. It means the same kernel is the first kernel x comma t. For finding the second, third and nth kernel, we are using the kn x comma t equal to a to b k of x comma z kn minus 1 z comma t and dz for n equal to 2, 3, 4 and so on. Similarly, for the Volta integral equation, we can find the iterative kernel by this method. And a new type of kernel is known as resolvant kernel or reciprocal kernel of an integral equation. Suppose that this is an integral for the Volta and freedom integral equation. The resolvant kernel is r, x, t and lambda, and for freedom Volta integral equation, the resolvent kernel is this. We can find the resolvent kernel by the method r x t lambda equal to m equal to 1 to infinity lambda to the power m minus 1 km x comma t. Some important formulas for solving the linear integral equation. One of them is Leibniz rule of differentiation under the integral sign. This is the Leibniz rule. D of dx, integration of this, where gx and hx are function, and function or some constant f of x t dt equal to g to h df upon dx dt plus f of x and hx dh upon dx minus f of x comma gx dg upon dx. Similarly, the formula for converting a multiple integral into the single integral. This is a multiple integral a to x y t and dt to the power n equal to a to x minus t to the power n minus 1 upon n minus 1 factorial y t and dt. In our next lecture, we will solve some example related to iterative kernel and using the Leibniz rule, also using the formula for converting the multiple integral into single integral, and also solve some question related to the linear integral equation in which the iterative kernel and some resolvent kernel are used. Thank you.